Hiya, I'm Carly from Kip McGrath Carlisle, and today we are looking at angle rules. So the first thing is we need to figure out our names of angles. So having a look at these guys over here, we've got A, which is our 90-degree angle, also known as a right angle. So it has to be precisely 90 and it's indicated on diagrams with the square in the angle. Okay. B is our angle that's less than 90 degrees, so it has to be between 0 and 89 degrees, and it's called an acute angle. And the only way I can come up with for that to remind children is to say it's a cute little angle because it's cute and little, so acute. Okay. C is our angle that's between a right angle and a straight line. Okay, so it is called an obtuse angle. So it's between 91 degrees and 179 degrees. Then we've got D, which is our straight line. Does what it says on the tin, it is a straight line and it is 180 degrees. Then we've got E, which is anything bigger than our straight line and less than 360. So it is 181 to 359 degrees. And it is called a reflex angle. And our last one is F, which is all the way around, which we could call possibly a full circle or around a point. And it is exactly 360 for the whole way around. All right, so those are our names of our angles. And then we've got these shapes here. And there's lots of different rules to remember. So starting at this end, which seems a bit backwards, this is a triangle. There are three angles in a triangle if we call them A, B and C. The three angles in any triangle, so whether it's isosceles, equilateral, right angle, scalene, any of those, always add up to 180. So A plus B plus C will always be 180 degrees. So that gives us some special rules for equilateral. Equilateral, by their nature, have three equal angles. So this one, and this one are all the same. So for that, we would do 180 divided by 3. So each of those guys is 60. Then we've got our isosceles triangle. So these two here are the same in an isosceles triangle. So for example, if we were given this one as 40 degrees, then from there, we can take that away from 180, which leaves us with 140. So these two angles are the same, so we would divide by 2 to work out that each of those is worth 70 degrees. So that's your angles relating to triangles. And then we've got rules relating to quadrilaterals. Now, quadrilaterals, quad means 4. Quad bike has 4 wheels, quads are 4 children. So quadrilateral are 4-sided shapes. So any 4-sided shape. So we've got squares, rectangles, trapeziums, parallelograms, and kites, all sorts of different ones. And they all have sort of one rule and some extra rules each. So the main rule is the angles in them always add up to 360. So no matter which shape it is, they add to 360. The easiest one being the square because there's 4 right angles, and the same in the rectangle, there's 4 right angles. 4 lots of 90, 360. So all quadrilaterals are 360. Same with this one. These will add up to 360. Now they might all be different. So these ones to me look like they're both probably 90, and then these two would be different, but it can be anything. They can all be 4 different angles. There can be some the same, but the total will always come to 360. Now, when we come to kites and parallelograms, there are some separate rules. So opposite angles in a parallelogram, so this one here and this one here, are the same. And the same going the other way. This one here and this one here are the same. So that's one rule for your parallelogram. And in your kite, these two here are the same. Okay, so that's some rules to do with quadrilaterals. Then we move on to our parallel line rules. So this is where you've got 2 parallel lines and something that cuts between them. 2 parallel here, cuts between them. And these rules apply no matter what way round things are. So whether the parallel lines go up or to the side, So you might see it in different orientations, but the rules still apply. We give them letter names, and also they have an official name. The letter name is useful, but the problem is that sometimes they're backwards or upside down, and so it can be a little bit tricky. But once you get into the habit of identifying them, which I would recommend using a highlighter in the exam, then they are quite simple. So I'm going to rub this off. Again, you've got this video, you can rewind it and write these notes down, but I'm going to rub this off because I need a bit of room to write this next bit. So we've now got these parallel lines. So we're going to start off with our Z angles. So if I draw a nice Z there, that angle and that angle are within the Z. So as we said, we call it a Z, but it can go backwards, so it can go that way as well. And your Z angles have their special name of alternate. And they are alternate because the angles are on alternate sides or opposite sides. And alternate angles are the same as each other. So if this one is 60, so is that one. So they are the same. Our next one is what we would call our F angles. Now it's a bit of a funny shaped F, but you can still see that that is an F, and the reverse of that would be here. Okay, and the angles are there and there, so both under the line, both on the same side as one another, and they are called your Fs, and they are corresponding because they are on the same side, so they correspond to one another. Okay, so they're on the same side, and they are also the same as one another. So these two are the same and those two are the same. Incidentally, if, for example, we were given this angle here, because we've got a straight line, we can take this one away from 180 to get this one, and then that would help us get this one, which is 120, and this one, which is 60. So often from having one angle, you can find out all the others on the picture. Our next one is what we call vertically opposite. So this one and this one are opposite each other, and the same going the other way. This one and this one are opposite, or also up here, that one and that one, and that one and that one. All of those red angles will all be the same as well, and the green angles will all be the same because of F angles for the reds to the reds and the reds to the reds, and also because of our vertically opposite. So vertically opposite are the same as well. Sometimes in questions, well, always in questions generally, they're going to ask you to explain what an angle is and why. Now, some people get into the habit of writing it in sentences. That's fine if you're comfortable with that. Some children hate writing sentences in maths, and so you can abbreviate things by, for example, if on this one I was wanting to find this angle here, and I know because of my Z angle it's 60, instead of writing a full sentence, I would just put a little line, say 60 alternate. That's enough information because it tells me the angle and it tells me what the rule is, and that would be enough to explain it. So you wouldn't have to write a full sentence that says this angle is the same as this angle because they are alternate angles on the opposite side. You can just simply label them like that. And we've now, oops, I've just realised vertically is missing a T, vertically, there we go. And now we've got this guy down here. So this one is what we call, and this one has a few letters, so that's another problem. We've got a C or a U, okay? Or even an N, I suppose, if you're going the other way up. So these ones are allied. And the way to think about these is that they come together within something. So you see how these are different sides of the line? This one is within inside the line, and they come together as kind of friends. So they're allies, they're together, they're allies. So instead of them being the same, they work together to make 180. So this one plus this one is 180. Because essentially what you've got there is you've got a straight line, because that one, because of the F's, would be the same as that one, and that one would be the same as that one. So you're using your F's, you're using your straight line, you're using all kinds of things, but two angles with inside parallel lines like that in a C shape, or if they're on the side, the U shape, or if they're underneath an N shape, are allied, and they add to 180 this time. So those are all our different angle rules. If anybody's got any questions, or if you're working on a particular problem and you just can't spot which rule you're going to be using, post a photo of it underneath and we'll have a look at it together, and I can talk you through which angle rules we're going to be using for those. Okay?